All right, so these warm-up questions are ones we looked at yesterday. It's the absolute value inequalities where you have to decide if it's an and or an or to start with. The first one, what do you think, and or or? Or, why or? Greater, good. So I'm going to put an or, and then you set up your two inequalities. Don't forget you flip the way the sign is facing and you change the sign of your number. Make it negative. Now we solve them both. I'm getting x is greater than 4 or x is less than negative 12. I'm going to go ahead and graph that. We always put 0 on our number line. I want negative 12. I want positive 4. They're both open circles. It's less than the negative 12, so I'm going to go to the left. It's greater than the 4, so I'm going to go to the right. What are your questions on the first warm-up? Second one, and or? And why? Less than, good. So we can set up our two scenarios, two inequalities. They're not really scenarios, they're both true. And we solve these. I'm getting x less than 15 halves and x is going to be greater than 9 halves. Remember the ands, we always write the smaller one in front, 9 halves, less than x, less than 15 halves. You start with the smaller one, x is in the middle, then the bigger one. So this is our answer. We can graph that. They're both positive, so 0 would be on the left, then 9 halves, then, 15 halves. Both open, and the x is in between there, so shade in between. What are your questions? Today we are finishing chapter 1. Like I said yesterday, we went kind of out of order. So 1.5 is actually the last one, even though we've already done 1.6 and 1.7. I thought 1.5 was a good Friday type of lesson. Not many examples, so it'll go kind of quickly. You'll have time to get your homework done. But it's all about problem solving using algebraic models. That's kind of a fancy way to say word problems. So some people look at word problems and they can just naturally sense how to do it. Some people can't. So if you're one of the people that can't, these 4 steps should help you solve any word problem. The first thing you want to do is assign labels. So decide what they're talking about. Did they give you the radius? Did they give you the height of something? Did they give you the distance? Did they give you the time? Figure out what they gave you and write it down. After you know all the parts of what they gave you, you can translate it into an algebraic model. So that's when you plug it into a formula. Then you solve the formula. Then you answer the question. Sometimes C and D kind of happen at once. But sometimes what they're asking you isn't really what you get when you solve the equation. You have to take it a step further. So just be careful on that. So if you are not someone who can do this naturally, some people just look at word problems and it makes sense. If it doesn't, try following these 4 steps. It might help. Here's number 1. I'll give you a second to read over it, then we'll start talking about it. So this says a water-saving faucet has a flow rate of at most 9.6 cubic inches per second. To test whether your faucet meets the standards, you time how long it takes the faucet to fill a 470 cubic inch pot, obtaining a time of 35 seconds. Find your faucet's flow rate. Does it meet the standard for water conservation? So on all of these problems, they're going to give you a formula, or it's going to be a formula you already know. Here is our formula for number 1. So the first thing we want to do is assign labels. So go through and see what you know. Do we know the volume of the pot? Yes, what is it? 470. Good. Do we know the flow rate of the faucet? No. So I'm going to leave that a variable. I'm just going to call it F. Do I know the time it took to fill the pot? 35 seconds. So I just labeled everything I know. Now I'm going to translate it to an algebraic model. So just follow along. with what you have here, filling in what you know. So we know the volume of the pot. We said it was 470. We don't know the flow rate. We said we were going to call it F. And then times how long it takes to fill the pot, 35 seconds. Step C in the problem-solving model is to divide by 35 and solve for F. So what do we get F to equal? I heard a 13.4 and I heard a 9 point something. Oh, okay. A lot of times we use, like I said, I like improper fractions, but since we have to compare it to this, I think it would be more useful to use a decimal. A lot of times in word problems, decimals lend itself a little more realistically, but I would accept that as your answer. But as a decimal, it's 13.4, something, 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 it keeps going on. Basically, though, all we need to know is it more than 9.6, and is it? Yes. So does this meet the standard for water conservation? Read the first sentence again. No. The flow rate is at most 9.6. So ours goes over that. So this does not meet the standard. No. Here's problem number 2 for today. It's about two sisters. Apparently they're elderly sisters. They live 500 miles apart. They decide to meet up halfway. Joanne leaves at 11, traveling 50 miles an hour. At noon, her sister Sue leaves, traveling 60 miles an hour. Who will reach the halfway point first? And how long will they have to wait for their sister? Where you're going to use distance equals rate times time. So this one's a little trickier than last one because we actually have two things happening at once. So I'm going to go through this problem twice. I'm going to start with Joanne. I'll just label it J. I'll do it in red. So do we know distance, rate, and time for Joanne? How far has she got to go? 250. Good. They're each traveling half of the 500. So she's going to travel 250 miles. Do we know how fast she's going? Her rate? 50 miles per hour. Do we know how long? This time is kind of tricky. This is how long they're traveling at this rate. Do we know how long she's going to travel? No, we just know what time she left. So that's going to help us, but that's not really the time. So don't put 11 in there. Okay? Now we can set up our problem. So distance equals rate. Oh, we know the rate. Times time. To solve this, we solve for time. And how long is it going to take Joanne? 5 hours. Good. Let's just kind of finish up with Joanne. So if she leaves at 11 and it takes her 5 hours, when does she actually get there? 4. So I'm just going to say 4 p.m. That'll help us when we're going to answer the final question. Okay? Questions so far? All right, we'll go back and do the whole process for Sue. Sue will be in green. Do we know Sue's distance? Same, good. Do we know her rate? Do we know how long it takes her? No, so we're just going to leave T as T. So again, distance equals rate times time. What do you get when you solve for T? For what? 0.1 what? 0.116. 6666666? Is that right? So since it's a repeating decimal, let's actually change this one to a fraction. It'll be more helpful. So do you guys know the button on the calculator that changes it to a fraction? Yeah, it's going to be 4 1/6. Do we know how long 1/6 of an hour is? 10 minutes. So that's why I said the fraction's kind of helpful here. You could do it with a decimal and then just multiply it by 60 to figure out how many minutes that is. But the fraction's really helpful on this one. So it's actually going to take her 4 hours and 10 minutes. So what time will Sue arrive? 4:10, right? She left at noon. So at 4:10, Sue's going to get there. So one sister, Joanne, gets there at 4. Sue gets there at 4:10. So who gets there first? Joanne. So my answer is going to be Joanne. And how long does Joanne wait? 10 minutes. So just say Joanne, 10 minutes. So this is one of those where you can do all the solving, but you still don't have an answer. So always look what they're asking you for if you have to take it a step further or if you're done once you solve. Questions on this one? Number 3 is our last example today. This one's about filling a pool. So a cylindrical swimming pool has a 5-foot depth, needs approximately 2,292 gallons of water to be full. To the nearest tenth, what is the radius? So they give us this formula to use. This is a volume formula. So the first thing we want to go through is plug in, figure out what you know, define your variables. Okay, so do we know the volume? What is it? Good. Do we know the radius? No, so I'm just going to call the radius R. Do I know the height? H is height. Yes. 5, good. And then remember, pi is just a number, so we don't have to define it. It's not a variable here. It actually has a value. So the volume, the radius, and the height is all we can really define. Now we can plug in everything we know. So 2,292 equals pi r squared times 5.
Do you want us to do like actual pi or like just 3.14?
If you have a pi button on your calculator, you should use it because it's more accurate. All right, I am going to solve for r squared. You can actually divide by 5 pi at the same time. There's 2 ways to enter it in the calculator. It's actually messed up my last class because someone didn't enter it in the calculator right. You can either divide by 5, then divide by pi once you get that answer. It's kind of a weird way to write it, but you can divide by 5, then divide by pi, or if you want to do it all at once, in the calculator you can divide by 5 pi, but make sure you use the parentheses, okay? Or else it thinks you're trying to divide by 5, then multiply by pi. So just make sure you enter it correctly. In the calculator, put it in parentheses. That will give you the radius squared. What are you guys coming up with? 145.9. Now, we don't want the radius squared, though. We just want the radius. So what would you do? Yeah, take the square root of both sides. 12.1. And we're talking about feet here. So 12.1 feet. And this one, actually, that is the answer to the problem they asked. We don't have to take it a step further. They asked for the radius of the pool. This is the radius of the pool. What are your questions on this one? All right, here's your homework. Be careful on this. Usually your homework says odd. This one says all, meaning at the beginning of class Tuesday, I'll give you the answers for the even, or if you're curious and what they are today, I can show you as well. But you guys have the rest of class to work on that. Homework check on Tuesday.